Hi, I'm sitting by my desk now. My computer's almost out of power, so I'm going to do the old-fashioned sit here and teach thing. I guess I'll leave my happy little face there. And then I guess I could use your name, Marissa, and then use your last name, right? Okay, she's in agreement. What do you think you're going to do with this first? That's factor. Yes, you're right. Divide out. And then what are you left with? And last hour, student said that, and I was really I wanted to get to something else, and I said, no, maybe not. But yeah, I think you actually should. And I apologize to that student. Not apologize, but I said, you know what? I think you were right. We should have done that. Okay, now I have a question. How do you find an X intercept for any equation? What do you plug in? Floor? Y, correct. You plug in the 0 for the Y. Now, Marissa and everyone else, the next thing that happens is an always when we're solving or dealing with rational functions. What would you do next, Marissa, to solve for X? What would you do in that scenario right there? Oh, that's cool. You can see my screen, but then in my picture, you can see the actual question right there. This is like a double. Anyway, nobody cares. Okay, so the question was, what would you do next? Do something about this, right? Well, we're not going to distribute it because you just factored it, right? But what would you do to both sides so you don't have a fraction anymore? Multiply by the whole thing. And then what's going to happen when you multiply by that whole thing is it cancels. And then what's that whole thing times 0 anyway? 0. So really what happens is you end up with the numerator equal to 0. That's an always when you're finding the x-intercept. And what is the x-intercept? Make it a coordinate, ma'am. 1, 0. You plugged in 0 for y, you got 1 for x. Mark it down, dudes. Every single time you find an x-intercept, it ends up being the zeros of the numerator, really. You set the numerator equal to 0 and solve because of what I just showed you there. All right, we'll get another student there. 13. Nice, lucky number. Okay, how do you find the y-intercept? Well, she got the x-intercept by plugging in 0 for y. 0 for x. There you go. What do you end up getting? Good. So what's -1 over -12? Ooh, it's negative over negative, which is... Okay, and then what we should do is be graphing these. And 0, 1/12 is very, very barely above the 0, 0 there. So kind of have to show that. Oh, that's not COVID. Sometimes just choke on my words. All right. How many people do we have here? Oh, that's Amber. Hey, Amber, what's the vertical asymptote? You remember that from chapter PR? Oh, the vertical asymptote comes from zeros of the denominator because you can't divide by 0. So what number when plugged in for x gives me 0 in the denominator? I highlighted it. So what number, if I plug that in for x, would give me 0 down there? What number plugged in here would make this 0, and therefore that can't happen? Can someone help her? Yes? I couldn't hear you. -3. Okay, so when you plug in -3, you get a 0 in the denominator. What ends up happening to the graph then is you get a vertical asymptote there. So x equals -3, 1, 2, 3, and we want to draw that. Oh, Amber, you're not going to like this next question. What is the horizontal asymptote? Do you know it? Or do you want to phone a friend, which is me? Does anyone even watch that show anymore, ever hear that? Who Wants to Be a Millionaire? Never mind. Do you know the horizontal asymptote? No? Okay, now here's how it works. You know what? I have something for you, Amber, and everybody else. It's on the calendar. It's this graphing steps thing. I just want to make sure I don't have it open yet. I got to move myself. Yeah, it is. So it's right here, graphing steps. Ooh, that was kind of cool. It kind of shows that red circle with this program here. And then this document comes up. And then here's where horizontal asymptotes are described. And it is rules. It's rules about the numerator and denominator's degree and what ends up happening. But really, it's what happens here. Amber, what happens when I plug in 1,000,000? Well, I'll tell you, for x, it becomes 1,000,000 minus 1, which is essentially 1,000,000, right? And then -4 times 1,000,000, which is -4,000,000. Minus 12, who cares? That's irrelevant. What's 1,000,000 divided by -4,000,000? What does that reduce to? Can someone help her? Go ahead. What kind of 1 over 4? -1/4. So the horizontal asymptote is y equals -1/4. Okay, let's go back to that graphing steps thing. And we might want to be like looking at this thing because it is pretty cool. It does show a lot of things that we're going to cover today. Right here it says when the degree of the numerator is equal to the degree of the denominator, then it's y equals the coefficients in front of those equal degrees. So it is y equals -1/4 because these are equal in degree. And we're going to have to remember that. Actually, we've already covered this. This is from chapter PR. You had questions about horizontal asymptotes. So how do we graph that? Oh, we just got to be really making it close to the x-axis, but not quite there. Then the last step is honestly to go to the graphing calculator. All right, got to move me again. I just can't get out of the way, can I? Y equals Claire. Second, y equals for fractions. And then we go x minus 1 over -4 x minus 12. You know what, though? I don't really need to do this. And many of you should not need to do this because I'm going to go ahead and hit graph here in a second. With these two intercepts here, the graph has to behave like this then above and then get closer and closer to this asymptote here. And there is no x-intercept here, so I bet you, darn tootin', that this thing is down here. And that's what I'll see on my graphing calculator. So we can use the graphing calculator at the end, but I really don't think many of you should have had to, right, because of some of the information that we got. So there you go. You got it exactly. This is so neat that we can see the picture here and here. Wow, it's like double notes. Okay. All right. So I like sitting here. Okay, I'll go ahead and do the domain for you, and then I can ask students later. The domain is everything but the x or the asymptotes. And then the range. Sometimes a horizontal asymptote can be crossed. We haven't been able to actually show that to you yet with an example. I think some of the homework assignments you'll see that happen, and we can discuss it maybe a little bit Wednesday. But the range actually is everything but that horizontal asymptote because it's not crossed at all. Those are definitely approaching but never getting to -1/4. So that's why the range is affected. Now, I am going to do this for this one by grabbing another student. These limit questions, which I'll maybe tighten these up and bring them closer here. Yeehaw. Limits. Now we got to do limits with another student here. Ooh, that's a crazy student. Never mind. Enter. Nice. Natalie, you ready? I don't know what she said. I think she might have swore. No, I'm just kidding. Hey, as x approaches infinity, what does y approach? So I guess I kind of have to do this way. As I plug in these big x values, what does y appear to approach? You remember this question from back in the day? Okay, so I guess I have to stand up and kind of point to it. Sorry, the movie. Right. So as x goes to infinity, I plug in this x value, I get this y value. I plug in this x value, I get this y value. The y values are always like right here. Where are those y values going? Oh no, they're going to this. They're going to this dotted line. What is that dotted line? Negative 1. Are you saying negative? Okay. Negative 1/4. You know, I feel like I'm already going to stand up here shortly. All right, and then as x goes to negative infinity, what does y go to? Now it's on the other side of the graph, which is kind of cut off. I should zoom this in. But as x goes to negative infinity, what does y approach? Negative 1/4. It's the asymptotes that it's approaching. All right, one more question. Watch my X and Y finger. Ooh, there we go. What am I doing? I could show myself up at the screen like this. Okay, now watch this finger. All right. Hello. Wait, do I see myself there? There we go. Okay. As X approaches -3 from the left side, that's what this one is right here. As X approaches -3 from the left, what does it look like Y is approaching? This is my Y finger. Negative infinity. And as X approaches -3 from the right, that's what that -3 plus means. So X comma Y, X comma Y, X comma Y. Where's my Y finger going? Positive infinity. That's what these are. You will definitely have these questions on your test. What? Oh no. What happened? I'm freaking out, man. I don't even know what to do. What happens next? New? I don't want new. I just want, how do I get out of this? Escaping? You know? That one? Okay. Oh. And then this is infinity, right? Isn't that what we said? Oh, that's just one question. Okay. We're not doing that one. This is Wednesday. So we'll do that Wednesday, okay? And then you'll have to do 3. So tonight, it says on your homework, don't do 3 and 4, but do everything else. A whole? How does that happen? Well, perhaps student number 17 will tell me so. Ryan, you always seem to get picked by the calculator. What should we do first on number 5? Or factor? What do you first factor on that? Take out a 3x, what are you left with? And we're good factors. What multiplies to 6 and adds to 5? And therefore, or what is the factored form of x squared plus 5x? There you go. And I knew you were a good factor, so I really shouldn't have to cover that anymore. But there we go. There's another iteration of factoring. Hey, Ryan, what do you notice on this one? Look at the numerator, look at the denominator. These cancel. And that is the crux of what a whole is. Because here's the idea. The graph of this is equal to the graph of this, what's called the reduced form of that, except that in the original graph, -2 is still not allowed as a domain value because -2 makes the original function still undefined. You get 0 divided by 0 if you plugged in -2 in the original. So I can't have that. This is an interruption in the graph, but it's not a vertical asymptote. It's a hole in a graph that now is discontinuous at this part. And then this says so even in the, I know I keep referencing the sheet that you can barely read. I guess I could zoom in. That would have been nice. Hey, that's smart, Mr. Samuelis, on your 4th time of doing this lesson. Wrong, that's 5th. Wait, what hour is this? 6th. This is my 5th time doing this lesson. Finding any holes? Substitute the value back into the reduced function in order to find the y coordinate of the hole. See, -2 comma exists for this graph, but it can't exist for this one. So that's why we're going to find it, but then make it a hole in this graph. I know that may seem confusing, but that is why we do what we do. So 1/3 times -2. -2 plus 3. Just for purposes of time, this becomes -6 times 1. So it's -1/6. Then I'm going to go back to red because graphing in green doesn't look all that great. And this is what I want to do to remind myself that there's a hole there. I put a hole there. Okay, so I know that when I draw this graph, I got to make sure I don't draw it there because it doesn't exist. I think I'm going to be standing up now. Ooh, I just don't like sitting. I like being on my podium here. Okay, now, who was I talking to here? Who was up? Oh, was it you? I think you did. You did the factoring and all that other stuff. Nice. 16. That is Amanda. Okay, now, how do I find the X intercept? I look at this now. I am going to graph this and not the original. And you know what happens when you plug in 0 for y? That is perfect. You end up with this. What do you do next? And you know what happens when you do that? You get this. Oh, no. Is that anything to solve? What does that mean about the X intercept? Doesn't exist. Nice. You nailed it perfectly. And then look at when you try to find the y intercept. What do you do when you find the y intercept? You plug in 0 for, I'm not even going to write it down. When you plug in 0 for x, my big fat head's in the way there, though. I'm going to move that down. 0 times 3 is 0. What's 1 over 0? Oh. 1 over 0 is which means what for the y intercept? Nice. Well done. Probably the MVP on that question because most other students struggle. Like, oh, how do you do that? I don't know what to do. Okay. Nice. All right. Hey, you're doing so good. Go again. Hey, what's the vertical asymptote? I just put an S at the end of that. So remember, those are the zeros of the denominator. Oh, look at the denominator. So that's what asymptotes are. They're what they can't happen. So what is it? Oh, I'd mark you wrong because what do you say about -3 for vertical asymptotes? What am I going to write there? Ah, x equals -3. Then what about this part? That's another one. X equals what? Everyone always struggles on this one. Who knows? What is it? 0. Okay, x can't equal 0 because you get a 0 in the denominator as well. I don't know why everyone always struggles on that one. And then, you know what happens when you plug in infinity or like a million? What's 1 over a million essentially, Amanda? What's 1 over a million? Nice. So what's the horizontal asymptote? Y equals what? You are correct. And then if you go to this cheat sheet here that I zoomed in on, there's the rules of asymptotes for horizontal. And we're on this one. When the degree of the numerator, I thought that came up as a thing. Huh. It's not doing the red circle thing anyway. But when the degree of the numerator is smaller, it automatically is y equals 0. But it's the reasons I'm going over with you. When you plug in infinity for x, what happens? Okay. Oh, I didn't draw anything. So I have a hole. Oh, and then this might explain why I don't have an x or a y intercept. Not the x equals -3. The x equals 0. That's why there's no y intercept. Got it. And then sometimes asymptotes can be crossed, but in this case, it's not. So y equals 0. That's why there's no x intercept, I guess, in this case. I don't have a whole lot of graph here, so I got to go get my mouse and then go to the picture because I don't really see much here. So probably this is a definite graphing calculator. What does it say the picture looks like? Clear? I don't care. We got to take the time here. Second y equals for the fraction. I am in the way. Okay, so x plus 2, 3x cubed plus 15x squared. Can't say I'm going too fast. Plus 18x. Ah! I just noticed I'm doing this wrong. That would have been bad. Okay, I gotta go back. This is great for the video, isn't it, everybody? Delete. No, what son of a, 3x. Oh, is this okay now? I don't even know. Delete, 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 delete. Oh my gosh. Why is this even? Oh, it's like a sauna in here. I'm sweating like a pig, screwing up left and right. My wife hates me. No, I'm just kidding. Just started complaining about my life now. I apologize. Finally got it. Okay, see, okay, there we go. So my asymptotes, we have the upper part. The graph kind of stops here. It doesn't. It's because of pixels. You got to know that this goes forever. Then you see that little slit there? You see that? That means we are above the vertical asymptote on the far left. Okay. All right, so we have this. And then don't forget about the hole. Hit that hole, and then come back down after the hole. And then we got this. Oh, that's a lot of stuff. Oh, I'm going to do the domain on this one, and then you're going to hate this. The domain. I wish it was back in the old Algebra 2 days where you could just say what it's not equal to. Because it's not equal to -3. It can't equal -2 because of the hole. I just did that wrong. It's -3 to -2. And then it's -2 to the other asymptote. And then it's after the asymptote forever. Oh my goodness. Would have been a lot nicer if I could just say the domain is everything but -3, -2, and 0. That was nicer back in the day. And then the range. I am going to cover it. And please pay attention because the range is a bugger. I think 5th hour yesterday, went and found the maximum here using the max feature on my calculator. And through memory, I think it was at -1.5, 0.14. The reason I did that is that's the range, guys. You have to understand range is y, and all these y values are covered all the way up to this maximum. Then there's a gap. Then the next time the y gets picked up is after this asymptote going up forever to positive infinity. You have to understand range, and just by looking at the picture. So with that being the case, the range is all the way down from -infinity all the way up to that 0.14 maximum value. Then it picks up again after the asymptotes, not including 0, because it's approaching y equals 0. So really, I did want to do that. And I didn't want to waste the time of finding the maximum like we did in the other class. Okay, and then I'm not writing these limit behaviors down, but I am going to get a student and see if they're paying attention here, right? Oh, putting the challenge on, man. Oh, 21 and then 16 again. So 16, get ready. 21's going now. She just like hit her desk. I don't know. So Amber, right? As x approaches infinity, what does y approach? So as I plug in these x values, the y's just get stuck like right here. What are they getting closer and closer to? 0. As x goes to -infinity, what does y approach? 0. I don't know if you can hear me on the video. Put that up here. And then as x, okay, let's pick one of these. This is why this gets nasty. I would have 4 different limits for this. Okay, you do whatever you want. You're going to have a test question where you have to know what I'm doing here. Amber, as I approach 0 from the left, where does y go? You see my finger? Huh? As I go 0 to the right, where does y go? Positive infinity. Okay, good. All right. That wasn't so bad, was it? Okay. Who's 16? Yay. What are you going to do first? How about a -2x? And then what are you left with when you take out a -2x? Nope. You take a negative 2x divided by 2x, and then what is, it's not plus 1, it's what? Minus 1. And then factor the denominator, simple MA. It's actually what multiplies to be negative 3. So it couldn't be 2. Oh, sorry. X minus 3, X minus 1. There you go. And then does anything cancel? Does anything cancel like the last one? No. So there's no holes. All right, we're ready to go. And I hope you guys got this all settled down, what we do on each one. Nice. Beatrice, right? We can say first names. We don't know who we are. What's the X Intercepts? Remember, the X Intercepts directly end up being the numerator equal to 0 because the denominator gets crushed when you cross multiply. So what are the X Intercepts? Oh, you're looking at the wrong spot. I actually wrote it over here too. The X Intercepts is the numerator set equal to 0. So what is X equal for this one? 0. This one? 0. Oh, 1. And then what is it for this one? You said it. 0. 0. So the X Intercepts are 1, 0. And then people, I just said this before, we had a similar situation with this. 0, 0. When you set that equal to 0 and solve, you get X equals 0. So I do have 2 X Intercepts, and we'll see it on this picture. Well, it's going to be tough to see, but we do. And then, Amber, what do you get for the Y intercept? By the way, 0, 0 is an X intercept, but it also is what else? So what's the Y intercept? What's the Y intercept? 0, 0. It's the same thing. And basically, how you find a Y intercept, you plug in 0 for X. And when you plug in 0 for X, you get 0 over negative 3, which is 0. So it still works out that way. All right, so make sure you got all the stuff figured out where I'm looking for certain things. Nice, 17. Ryan, what's the vertical asymptotes? Love it. Everyone sit up in your desk when you get called. Ooh. Who's sweating right now? I know I am. All right. No one else, apparently. Good thing it's 95 degrees with this mask on. Ryan, what you do is you look at the denominator. What? Say that one more time. X equals what? There you go. 3 and X equals negative 1. And we'll see that behavior when we go to the picture. And even if this isn't clicking, when you go to the picture on the calculator, it should click. Oh, okay. I can see the graph behaving weird by negative 1 for X. And I can see the graph behaving weird by 3 for X. You know, that classic behavior. And then Ryan, it's that rule again. I just went over it. These are equal in degree. So what is the horizontal asymptote? Calling you out on this one. Oh, when the degrees are equal. Actually, it was the one before that. What is it? Negative 2. So that's when we go to that cheat sheet that I put online that I stole from the internet that has really good steps identified. Not necessarily in the order that we're attacking them. I think we're going to verbalize some of this other stuff. And then on this one, okay, actually, no. This is what you really should know. Notice there's no X intercepts over here. So I guarantee you that the graph is down here. If there's no X intercepts, it would have to be below that horizontal asymptote. Same thing on this side. There are no X intercepts over here. So I guarantee we're going to have that. Now in the middle, I don't know, a whole bunch of stuff could happen. It could be going down or up. It doesn't really show me that. We could plug in points, but these days we have the graphing calculator. I guess I'm talking to the internet right now. Back in the day, like 10 years ago, students had to plug and chug and put numbers in to find out what the coordinates are. These kids these days got it so easy. The technology and their phones, and you should watch this documentary on Netflix about how bad those phones are. It's actually a guy that worked for Google that quit Google because he saw how damaging what was going on, like in the world, and then decided to advocate kind of against technology. Now there's a Netflix documentary on that. Anyone ever hear that? I forgot the name of it. Do you know the name of it?
The Social Dilemma.
The Social Dilemma. Get that on the internet. All right? Part of my lesson today. Did you watch it? Pretty powerful, isn't it?
Yeah, it is pretty good.
At least you have to admit it brings up good points, correct? Now, I don't know what those points are because I haven't seen it, but I've talked to my friends about it, and they said it's a must-see with my kids. It's part of the problems that we have today, isn't it? Kind of talk about how it just makes people just one-sided because it just, your phone just keeps training you on like what you search, and it just keeps pushing you to one side or the other. There's no more in the middle anymore, and that's why everyone's like, that basically what I just did right there describes Twitter in a nutshell. Okay, and that's all it is. It's a bunch of gibberish. Oh, this is a great lesson. All right, let's go to the next one. Okay, I forgot I was going to do some limits, but can we just move on? Let's move on and do limits on the last one. Now, this is why number 12 and number 11 I did, because I felt we need to have one like from chapter 1 when we talked about transformations. So hopefully you see that this is a different question, like as far as how it is structured. This is structured in transformational format. It's not polynomial divided by polynomial. It's taking this 1 over x function and doing a couple things to it. I guess I should be mindful of the camera as I move around. I kind of like that it shows the screen as well. Great. The negative flips that green graph. Do you remember this? Right. And then let me get a student here. Wish I had like 2 calculators I could do 2 different things with. Nice, 16. Who's that? Is that you again? Oh, all right, let's go. Okay. All right, so what happens what number, when I plug it in for x, it gets 0 in the denominator? So there's the 3 left. What got moved 3 left? X equals 0 from the parent function. So now it's at x equals -3. And then the 1 is 1 up. Hey, one more question. What's 2 over a million? What does that essentially become? I know I ignored the negative. I don't care. Plus 1 is 1. The horizontal asymptote got moved from y equals 0 to y equals 1. So now y equals 1, x equals -3. So they're staring you in the face on this one. All right, the vertical and horizontal asymptotes. I think she's done enough today. Unless she gets picked again, I can't. The calculator is the ruler of this class. Nice. A swear word. I should write you up. Well, I know you didn't swear, but it really seemed like you wanted to. So X Intercept, what do you plug in for who? What do you plug in for the X Intercept? Yep. Okay, and then how do you solve this? You're right. What would you do first? Or subtract 1. You did a double negative on that. Subtract 1, and then what would you do next? And then don't you agree that that would distribute that -1 to that when you multiplied? I hope so. And then what's x finally equal? And then we'll write that as a coordinate. This is super fast. Good job. Is it my writing?
No, my eyes.
Does this help? Yeah, add 3. Oh, it's -x equals 1. So then what does that mean 1 equals? -1. So it's -1 comma 0. We should write that as a coordinate. And then let's get what if it's 21 again? Oh, it's 15. Nice. How do you find a y-intercept? What do you do? 4? Okay, now this is what happens. I'm going to help you out like Lexi Samuelis would. She knows she's going to be adding fractions, so she changes 1 to 3 over 3. What's -2/3 plus 3 over 3? That's why we do it. We don't need to go to the calculator. It's actually an easy question. Okay, so -1 comma 0. I didn't draw anything. -1, 0. 0, 1/3. Okay, I bet you know what's going on with that. X equals -3 is right chaw. And then y equals 1 is right here. And then I know what's going on. Because I could see this, these two X and Y intercepts, this has to keep going. Got my hand stuck there. Then has to keep going. And then there's no X intercept here, so it must be up here. And the reason I also know that is this got flipped off that I circled to the right. So it is above and below like this, going left to right. You can go out and check your calculator. I didn't graph this one in the calculator, I think, in most of the classes. Okay, I lied. One more student. Hey! Okay. See that? As x goes to infinity, what does y go to? Oh. And then as x goes to negative infinity, what does y go to? 1 and 1 for both of those answers. Then as x approaches -3 from the left, where does y go? Positive infinity. And as -3 from the right side, negative infinity. Okay. And then domain would be everything but -3. Range in this case would be everything but 1, because there is that interruption there. All right, we're going to lock it down now. That's good. Don't forget about that internet stuff. Twitter. Boo!